Our next protocol is going to be SNMP. SNMP stands for Simple Network Management Protocol, and it is a protocol which allows us to manage certain devices over an IP network. So say we have a printer that we need to have a way that we can manage this device, that we can see the information and collect information from it, such as how much printer ink is left, how much print jobs have gone through, if there's any paper jammed in it. SNMP, the Simple Network Management Protocol, will allow us to do that. Simple Network Management Protocol, if you hear of a network protocol which allows you to see information such as you have certain SNMP devices which will send you information such as the temperature in a room or the temperature of a device or how a device is, simple information as to how a device is functioning. That's SNMP. So if you get a question like which of the following protocols is used to manage a device which lets you know the temperature of a rack server, or which lets a protocol which manages the temperature and sends you alerts on the temperature of a rack server, then that would be SNMP. SNMP works over two ports. We have port 161, which the agent runs on, and port 162, which is the management console. SNMP works on everything from printers and routers to other network devices and servers. So it's a very robust protocol, and it's used in a lot of management of simple quantities or simple indicators and simple alerts on different devices. Now, the agent on port 161 is on our device, and this is accessed by our management console of the device, which runs over port 162. So by using our agent on the device, which is sort of like, you think of a agent in the field, which actually goes out and collects information and then sends it back to the management office. The management office is going to be the ones who stay in headquarters and who are going to access that information sent to them by the agent. So SNMP allows us to use that management to control those devices without necessarily having to go to every single device and plug into it with a special cable, or have it go to every single device and manage using those little printer arrow keys and everything on the device. We can connect to our device using SNMP and then manage our printers or manage our devices that way. Next we have NTP. NTP runs over port 123, and it's a UDP protocol, and NTP stands for Network Time Protocol. Network Time Protocol allows us to set up our different devices to synchronize time across our network. Our different devices may need to synchronize their time for different transfers of data, so it's important that they have the time that's the same. We don't want to have an environment where all of our different devices are off by a minute or two from each other. So using Network Time Protocol, we can set up a single server that manages the time and keeps it consistent throughout all the devices on our network, and then simply manages that time and sets the time on all of our devices by using NTP, Network Time Protocol. And this is going to be transmitted and received over port 123. And then we have TLS. TLS stands for Transport Layer Security, and it's the successor to SSL. I stated in a previous section incorrectly that we have our HTTPS running over SSL, when actually our HTTPS now, by current standard, actually runs over this TLS. Now we have here that our TLS port varies, and we mentioned earlier that that's because TLS runs over certain applications to provide them with a layer of security and encryption of the data that they're transferring back and forth. So TLS, we aren't just running data over transport layer security. We aren't just running TLS data. We're running other protocols data over TLS. So for example, HTTP. HTTP, we need to have a secure version of that, and that's HTTPS. HTTPS is secure because we run it using TLS. It runs over TLS on port 443. So HTTPS, HTTP secure, which runs using TLS, is running over port 443. We also have LDAP, and LDAP has a version running on TLS, which is a completely different port. So we need to understand that when we see TLS, TLS is going to be used on our different ports based on what protocol they're securing. So if we hear TLS in the context of HTTPS, then HTTPS would be port 443.